Okay, I think that's my cue. Welcome everybody, and welcome to everybody that is online as well. My name is Nate Ebel, and I am very excited to be with you all here today talking about adopting Kotlin Multiplatform in Brownfield applications. So really the question that drives this whole talk is how can your team start sharing code using Kotlin Multiplatform? And really this talk is going to be informed by the work that my team has been doing for the past year and a half or so, going through that same journey, figuring out what works, figuring out the things that did not work for us, and hopefully bringing that all in and helping you all in your journey. So just a little bit of where we're going here. We'll talk about the organizational buy-in component of this, as we talked about last night in the roundtable, getting other people in your team and your organization so solidified around this idea of a code sharing solution is very important. We will talk about how we started to solve the key technical challenge that we needed to work with before we could really go into production. And then we'll talk about the lessons learned, how we're using it today, what the future looks like for us, and hopefully provide some context where you might see your own journey in there. So just out of curiosity to help set the stage here, who is already using Kotlin Multiplatform in production? Okay, handful of people. And how many people are considering it or interested, and that's why you're here right now? Okay, awesome. That's pretty much everybody else. Great. Hopefully this will be helpful for all of us. So for everybody that raised their hand the second time there, that are interested in it, want to know more about how they could go about it, how we went about it, that's really what this is going to be. It's going to be kind of a Kotlin Multiplatform integration roadmap. Hopefully this can give you some guideposts, a rough high-level plan of how you could approach this topic. To help with that more, for after the conference, or if you just would prefer to read rather than listening to me for the next hour. I just yesterday finally got around to publishing the first 3 of a handful of blog posts on what we've been doing. So exactly all of these technical challenges, things like CI, structuring the project, ultimately down the line, more things about packaging, Swift packages and stuff. All of those stuff are coming in blog post form. Yay for conference-driven development, helping you finally get those all out yesterday. So if you want, you can check those out and read more. So let's start then with this idea of organizational buy-in. This was really the first place we needed to start. So to help with that, I'm going to give some context to our team. I think code sharing and the choices made around code sharing really depend on your team and the skill set and the makeup and all those things. So my team, I work at a company called Premise. We have about 16 developers, 8 Android developers. I had 7 and crossed that out. There were 7 iOS developers when I left for this trip. Apparently there's 8 now. So we're up to 16 mobile developers now. We are kind of an interesting position that I'm sure a lot of this group could appreciate. We actually tend to build a lot of things Android first, which is not often the case, but I think that is relevant in a Kotlin multi-platform discussion. We are localized in 40 languages. We have monthly active users in the realm of several 100,000. So we're not a really tiny team by any means, but we're also not working at the scale of hundreds of developers either. So we're kind of in a sweet spot there. So the first tip here, just to throw it out right away, there'll be 5 tips if anyone wants to count, but the first tip here is to let the problem define the solution. I kind of alluded to this yesterday in the roundtable. We did not set out to use Kotlin Multiplatform. We didn't say, let's use Kotlin Multiplatform, let's go find a problem. We started with a problem, and our problem was that our analytics were a mess circa 2 years ago, probably longer than that, but I've only been there for 2.5 years or so. So we set out to solve this problem. So we spent several months, we put together a little working group of some of our mobile tech leads, our VP of engineering, and we started thinking about things like standardizing our analytics events. We defined clear sets of patterns and rules for each type of event, and ultimately our output artifact of this exercise was not code, it wasn't Kotlin Multiplatform or anything like that. It was a doc, as you know, most senior and staff level engineers spend all their time in these days. So we had this doc, and we started to come to this next question then. All right, we have these shared rules, and the whole purpose of this exercise was to codify the thinking around analytics across our whole mobile platform. So it's a natural question to think, could we codify this in code? So this starts to bring you into this idea of shared code for shared thinking. So now we're starting to get into a multi-platform solution, a cross-platform, Kotlin Multiplatform, whatever you want to think about it. And so for me, this is where I started to get excited. As a Kotlin fan, someone that had been following Kotlin Multiplatform, I'm excited inside. I'm thinking, finally, this is the perfect use case for Kotlin Multiplatform. This is my best bet to pitch this as a technology. So I started thinking about how am I going to do this? How am I going to craft my argument to make that case that, hey, I think this could work for our team? And as I kind of spoiled yesterday in the roundtable, turns out I did not really have to do that. Our iOS tech lead at the time actually came to that first. In the same call, I was going to bring it up. He threw out that idea of, hey, we should share some code for this. I've heard about Kotlin Multiplatform. Nate, you seem to know a lot about Kotlin. What do you think of that idea? And internally, I'm thinking, yeah, you beat me to it. But externally, I'm like, hey, that's a great idea. Let's try Kotlin Multiplatform. So this actually brings me to the first and only fake tip of this talk, which is to just find yourself an iOS team that wants Kotlin Multiplatform, and it simplifies a lot of the discussion around whether or not you should use it. It's probably not the most helpful tip for people. That's why it's labeled fake tip. But the actual tip number 2 here is to consider both the technical and the human factors. Again, I think part of the discussion yesterday and part of the general multi-platform discussion, it really needs to come down to your team, how your team works, the size, all of these other things. I think through the history of multi-platform discussion, whether it's Flutter, React Native, Xamarin, Kotlin Multiplatform, a lot of the examples that have been out there over the years come down to the teams and what your team was already kind of predetermined to. So I think it's important when considering Kotlin Multiplatform or anything else to, again, think about not just the code and whether the code works, but whether that solution will work for your team. And so for us, we ultimately said, yes, we think this will work for us. Here's a handful of the reasons why. We had this clear set of business rules to codify, so we had a very clear idea of what we wanted to build. We knew that we wanted to share logic across iOS and Android, but also could see use cases for sharing it on our back end as well. We didn't want or need shared UI, so we didn't need the shared UI for analytics. We also didn't want it if we again started to think about an N+1 solution. We weren't sold on needing UI, so that helped us rule out some other alternatives. We had engineers well-versed in Kotlin. Our whole Android team has been using Kotlin for at least a couple years, some of us much, much longer. Everything we write is in Kotlin, so that was a very comfortable thing for us. We had folks that were comfortable doing non-trivial configuration with Gradle builds, which was another thing that proved very helpful 2 years ago. Not as big of a requirement today, I would say, but back then it certainly helped. And then we viewed Kotlin Multiplatform as very low risk. The on-ramp, the barrier to entry is very simple and fairly easy off-ramp as well. We thought, hey, if we try this and it blows up in our face and goes wrong, pretty easy to just pull that code back into the Android project, and harder for iOS, but not that wildly difficult to translate into Swift. And then ultimately, this last point here, possibly the most important one on this slide, we had engineers that were willing to prototype, willing to learn, willing to try new things, and willing to share that with the rest of the team as well. So we went through all this mental exercise. Up to this point, we haven't written any code or anything. We start thinking, okay, how do we actually go about validating this? So this is likely where a number of you are based on the hands we saw raised earlier. How do we validate Kotlin Multiplatform for our project? So these are just, again, a handful of the questions we had, and these are going to be kind of the questions that serve as the outline for the rest of this talk. We'll talk about where is this code stored, how are we going to structure the projects, what targets to choose, what are our output artifacts going to be, how do we have a nice efficient local development pipeline, how do we have this automated in CI for low-cost releases, how do we ultimately integrate these into our existing applications? I think that last one, again, is interesting to point out because a lot of the examples out there, a lot of the documentation for Kotlin Multiplatform, they focus on the greenfield aspect. You say, hey, I want to try this out, and they show you a project where everything lives side by side. It's very simple. You don't have tech debt on 2 platforms to deal with. it simplifies it a great deal, which is awesome for learning, not as helpful when you're out there in the real world trying to figure out if this will work for your team. So up to this point, we've been kind of linear, kind of going down the timeline of our work with Kotlin Multiplatform. If you'll permit me, I'm a little hand waviness here. I'm going to jump ahead and basically say that we created a sample project. We'll talk a little bit more about that. We answered our technical questions. We'll talk a lot more about that. And then ultimately, we got to this point and said, okay, let's ship something. Let's see if for real this works out in production. So this was the other big question, is sort of what do we want to ship first? And I think this is another place where there's a lot of room for your team to think about this yourself. We could go, KMP all the things, let's start writing big new features, we could rewrite things in Kotlin Multiplatform, or you can kind of go the other direction, which is where I would recommend and where we started, which was to start with something very, very small. And so for us, our small thing was literally one string constant, I believe, that we defined in shared code, exported to both platforms, and used to log an analytics event in production. At this point, we hadn't done anything of actually building APIs. We hadn't codified any of those rules yet into code. We just shipped a constant just to make sure that we could get an end-to-end development experience that worked, and then also didn't blow up our app when we were out there in the wild. This was actually, just as a fun side note, this was another spot that iOS beat us to this. They actually had this out in the wild before we did. Again, kind of exciting, kind of frustrating for the Kotlin enthusiast in me. So at this point, we had the green light. So we'd gone through all this, we'd answered the questions, we knew it worked in production, and we kind of went on our merry way about building out our APIs and doing more. So we'll talk about everything that happened after this point later. But for now, we'll go back to this core question then. So once we determined that we wanted this solution, how did we build it? How did we prove that it would work? So again, you have some different thoughts here, but for us, we took this approach of thinking like library developers. We had two separate repos. We knew we didn't want a solution that were going to require us to merge those repos. We didn't want to add additional setup instructions to each of our project to do things like integrating maybe Git submodules or things like that. We wanted to try and leave our main projects untouched as much as possible. So that led us to this idea of basically building a first-party library effectively. So the final solution for kind of local development, deploying to CI, integrating the app looks something like this. And we're going to walk through the individual components. But basically, we have shared code repo. We have a CI pipeline kind of working across there at the top that spits out artifacts for the JVM and Android to an Artifactory server. We have a repo that serves a Swift package for us, and we integrate those into our production app. And on the local development side, developers can make changes locally, push those to sort of their local locations, integrate those into the app as well. So we have sort of a streamlined workflow for both use cases, which is really important. We'll talk about why later. So let's just revisit our primary questions again real quick. Where will this code be stored? How are we going to structure the project? What targets to choose? How to distribute a multi-module artifact to iOS? How do we build the output artifacts in general? How do we build, deploy, and test locally? How do we do it again in CI for low cost? And ultimately, how do we integrate all of this into our existing Brownfield applications? So where will this code live? We already talked about the fact that greenfield applications tend to all be packaged together. And that structure looks something like this. We have a single project, and within that, we have iOS, Android, and shared code. So this is typically what it looks like if we do any of the main tutorials on Kotlin Multiplatform. But like I said, this doesn't really work in a scenario where you already have separate projects and you want to integrate into those. So in an alternative structure, we have something that looks like this. We've got our Brownfield iOS application. We have our existing Android application. And we went this route of creating a new separate project for KMP. So in this scenario, the existing projects are untouched other than ultimately integrating a new dependency like we do all the time. The shared code, however, is brand new, exists in this other repo, and this whole exercise is basically comes down to how to get that code integrated over into the other projects. So within this then, we have to think about how to structure the code within the new project. And again, we have some different scenarios to go about there. In a very simple case where we have sort of a single shared module, in this case when I say module I mean literally a Gradle module, sort of one unit of compilation within the project, we might have something like this. Just a single Gradle module called shared where all of the code lives, and you might have separate source sets in there. So you might have just a common main source set, maybe you have Android main, iOS main, maybe you're doing lots of fun things with Kotlin Multiplatform and you've got watchOS and tvOS and all the other things in there, but it would look something like this. So we kind of came to this idea. This was where we landed on initially. This is a good place to start from if you're thinking about integrating KMP into your mobile applications, but we paused for a second here and asked ourselves, is this the right set of targets for us? As many of you know, maybe some of you don't know, Kotlin Multiplatform supports many targets. We've got iOS, we've got Android, we've also got JVM, Mac, Linux, Windows, IoT. We've got a lot of targets out there, more than I could fit nicely into this one slide. So we actually asked ourselves, hey, do we actually specifically need Android here, or could we make this JVM? And it turns out for our use case of analytics, JVM was perfectly fine. And by choosing JVM, we also made it easier for us to integrate into our backend services, should we choose to. So again, just another kind of general thing here is to think about exactly what you need. If you're building something very generic like constants or, again, in our case, analytics, you probably don't need it to be Android specific. And by making it JVM, you give yourself more options in the future. To configure build targets in this sort of one project setup, it looks something like this. In our sort of, in this case, that should actually say shared build.gradle.kts. But in the build script file for that single module, we have the multi-platform plugin. And then within the Kotlin configuration block, we can add whatever targets you want here. So in this case, JVM and a couple different iOS targets. Then we need to define the source sets for each of those. If we need to customize code for a given platform, then we need to declare a source set for that, and that becomes the place where we could put that code. So in this case, we could have common main, or we could put individual code for the JVM or the various iOS targets. And then finally, just a last little bit of configuration here to wire all of the iOS targets up together. Now, if you had a very simple use case and you just needed common main, you could omit some of this stuff. So again, this is where having some Gradle understanding is helpful, but it's a lot better than it used to be. So with that, we kind of have a basic idea of how code could be stored, how a very simple project could be structured. We then started to go on to this idea of how do we distribute all of this stuff to the projects once we've created the code. So again, let's come back here to this idea of having a single Gradle module. It's this single sort of compilation unit with all of our code in it. And at the moment, it's called shared. But we started to think about what an N+1 solution to this would be. So we imagined, what if this actually goes well and we want to do more stuff here? Would we want to put all of the code into this one single project? And so we imagined ourselves actually replacing shared with something more specific. What if this was specifically called analytics? And then what if it goes well, and not only do we have analytics, but we have other things like DTOs, networking, recommendations, deep linking, more and more features possibly. We didn't like the idea of putting this all into one project, separation of concerns, all that kind of stuff. We wanted these to be able to live a little bit more independently of one another. So in this sort of scenario, on the Android and the JVM side, we can very easily export individual jars or AAR files for each of these. Effectively, in this case, we're building X number of individual little micro libraries that we can then integrate. Those could be individually versioned if we want. There's a lot of flexibility with that. However, with this structure, it does not actually work on the iOS side of things. This is a limitation of the Kotlin Multiplatform plugin at the moment, which is that we can only generate a single output XC framework for a given Kotlin Multiplatform project. So to make this project structure work, where we have multiple sort of functional modules, as I like to sort of call them, we actually need to do a little trick here. We need to introduce effectively a wrapper module, again, a wrapper Gradle module in this case. This one, we reintroduce that name of shared. This shared module then depends on all these other individual ones, and we can generate an XC framework and integrate that through like CocoaPods or Swift packages into our iOS project. So while on the Android and the JVM side, we're generating individual artifacts for each functional module, on the iOS side, we have a single output, which is the XC framework. This is a little cumbersome to get set up at first. However, it does work quite well. It has scaled quite well for us so far. We haven't had any issues with this. So to create this sort of shared composite module, we'll take a look at the Gradle configuration for that as well. So we need the Kotlin Multiplatform plugin, once again. We need to define an XC framework. This will again be kind of our output. And then ultimately, we have to tell the plugin what to put into that framework. So in this case, we list off all of the iOS targets that we want to be included here. And then for each target, we add that into the framework, and then we make sure that we add any of those dependent modules and export them along with the framework. So this will make sure that all of those symbols and everything that are generated actually make it into the resulting output XC framework for us. And again, have to do the same thing with the source sets here to set everything up and provide those dependent projects as part of that final API. Okay, so we now know how we can structure a multi-module project and how we can handle the outputs for all of those. Let's talk a little bit more about those outputs and how exactly do we get access to them. So again, on the Android side, the JVM side, we're working with AAR files, jar files, and we can use the Maven Publish plugin to do the heavy lifting for us in terms of actually publishing these artifacts to our local server. On the iOS side, we're generating an XC framework, like I said, and again, I mentioned CocoaPods or Swift Package Manager for integration. Our team has been using Swift Package Manager, works fairly well, all things considered, given the limitations of Swift Package Manager, but we'll talk more about that in a moment. So for the JVM or the Android side, within a given sort of functional module here, in this case our analytics build script, we'll add the Maven Publish plugin. And then we need to, in this case, make sure that we have the Android library. If this is an Android specific publication, if this was just strictly a JVM one, we wouldn't need to add the Android library plugin. And once we have the sort of plugins defined for that functional module, we can define how the publications should be generated. So in the case of the JVM publications, those are generally handled by default for us. On the Android side, we can add this publish all library variants, and that will make sure that the proper publications are generated for us. And ultimately then, we can invoke the Gradle wrapper. We can say build, publish to Maven local, and this will publish all of the output jars or AAR files to our local Maven repository where we can then integrate those. Or we could publish those to our remote Artifactory server, which we'll talk about in a bit. On the iOS side, for this sort of local deployment model, we started off using the multi-platform Swift package plugin to take the generated XC framework and generate the required Swift package file. As we mentioned in the roundtable last night, there is one main issue with that library at the moment, which is that it doesn't have M1 support. So there are some forks of that managed by the community that have added that, or in the case of our team, we ended up replicating the bits of that project that we needed with, I think, 2 simple Gradle tasks. So this slide is representing sort of where we started, but it's not necessarily our end state. But ultimately, whether it's this plugin or your custom Gradle tasks, we generate a Swift package. You need to know things like the Swift tool version, target platforms that you're supporting. The distribution mode is an important one. We started off with local distribution mode. That has worked well, but we've run into limitations with that. I'll talk more about that at the end in terms of like the challenges that we faced. But ultimately, again, we end up being able to run the build task, and then we have a create Swift package task that generates the XC framework, generates the package.swift file needed for us, and then we can point Xcode at that file. So in both of those scenarios, we now have something on our local machine. We can integrate that into Android Studio, IntelliJ, or Xcode. We can very quickly make changes, test those out in our apps locally. So once we have that, the next big question was how do we do this for our CI workflow? Whoops, I got ahead of myself. So here's kind of the overall flow then of what that local deployment model looks like. So on Android, we published a Maven local, which drops the artifacts into the local M2 directory. And then in our project, we can add Maven local as a repository in our build script, and that will resolve any of those local dependencies. And on the Xcode side, it's very similar. We create the Swift package, which just outputs it to a build directory in our project called shared/output/Swift package. And then we point Xcode at that and import it as a local Swift package. So now to CI. So the CI workflow looks something like this. There's lots of individual steps. I outline those steps in much more detail in one of the blog posts that I alluded to before. Check that out if you want to learn more about the CI part. But ultimately, we check out the code, we set up Xcode, we set up Java, we run build, and then we need to generate those artifacts. So again, on the Android side, we integrate the Artifactory plugin, which is what we use to publish our published Maven publications. But the publications that we generate, we need to publish those to our Artifactory server. So we use that Artifactory plugin to do so. And then we set up that publication spec using the Artifactory DSL here. We're using the Kotlin script for our Gradle build scripts, which is a little bit clunky on the Artifactory DSL. So this is kind of a pseudocode implementation of it so as to not scare anybody away. But the core of it is here. We point it at the URL of our internal Artifactory server. We add the location of the repository within that server, and we add credentials. And so anything that any publications we generate, whether jars or ARs, those will end up getting published to that Artifactory server. Oh yeah, and then the last step here is we tell it which publication. So in this case, we tell it to be on the lookout for JVM publications. If we were an Android module, we could do Android. We can mix and match here. And then ultimately, like I said, on the consuming side of this, we need to point our project to that local, or to the internal Artifactory server so that we can resolve any of those dependencies. And then we add a dependency on it, in this case, your package.analytics 1.0, however you would with other dependencies, the integration is really no different. This is where it was nice to treat this as a first-party library because the integration is exactly the same as with any other dependency that we built. So we've got our publish to Artifactory task now. So we do that publication to the Artifactory server. Now for the Swift package side. And this is the side that gets a little bit more complex. So to host our Swift package and to provide it to the project, we're using something that I still find strange to this day, which is that we host the XC framework and a package.swift file within a GitHub repo. And if you point Xcode to that GitHub repo, it can resolve that package. So we set up a second repo here called Mobile Shared Swift Package. And all that's in that repo is the framework, a package.swift file, and a .getignore file. The shared framework is what we build when we run that build task and the create Swift package task. The package.swift file is also generated from those custom Gradle tasks that we wrote. And really, this is all that it is. I think this is more or less an exact copy of a package.swift file for a local distribution. So I mentioned before that this is using sort of a local distribution model or a binary, more specifically a binary local distribution. So effectively, this flow here publishes the full XC framework binary to the repo and then syncs the whole thing down. Now this is where I'll mention the challenge with this, is that you're checking in XC frameworks to your repo. And a couple XC frameworks is not that big in size. If you start doing this for a year and a half, checking these frameworks in over and over again, pretty soon cloning that full repo is multiple gigabytes and takes a long time to sync. And Xcode is not smart enough to do a shallow clone of the repo and just check out the one commit it actually needs. So if you have to do like a reset packages within Xcode, which again, surprisingly enough to learn from our iOS team, they do all the time, that can take a really long time to sync. So this is one of those caveats I'll mention here, is that this is not the most efficient long-term solution. I'll talk about that later, but this is a very easy sort of immediate short-term solution. So once we have the package, whether it's the short-term or the long-term solution, the integration is the same. We go into Xcode, we add new framework or library, we point it at the GitHub repo, and we have to make sure we're authenticated with GitHub to access it. We add the package, and boom, Xcode can now resolve that Swift package for us. And then within the CI workflow, to make all of this work, once we've built that package, once we've pushed the code, we need to commit that code to that secondary repository so that that new framework is there, the new package.swift file is there, and then we have to tag that release so that we can resolve the version. So then we tell Xcode, hey, go look for version 1.2 of our library. It goes and looks for that tag in that external repo, grabs that version of the project, and uses that version of the XC framework. Okay, so that kind of brings us to the end of these then. So again, just to review this, we've got our shared code. We've got a GitHub Actions CI workflow where we generate the AARs, the jars, the Swift package, and we host those either in a local or an internal Artifactory server or this separate Swift package repo. We integrate in their app, and then we have a similar local development model. So that's kind of what we did to get started. I'll kind of close this out quickly then by talking about where we're at today. So today we have all of these use cases. We've got analytics, we've got deep linking, performance, recommendation, security, and the most recent one that we've been investing a lot in is shared networking now. All of that said, while we have enjoyed this, we have found this useful enough to continue to invest in it, it's not without its challenges. So some of the challenges that we've experienced, some build time issues, challenges with the Swift package generation, sync times, API usability, shared ownership. So let me just quickly talk about these and what we're doing to mitigate this. Building XC frameworks takes a long time. Linking all the binaries is not a fast thing. I think, again, that was alluded to in the roundtable. So a really helpful thing that we've just started to do is to configure our build in a way where it's easy for developers to disable the targets they're not needing. So if I'm an Android developer and I'm just trying to prototype something, I don't necessarily need to be building all of the iOS targets on every build. So we can add a flag, skip iOS, and we will skip all the iOS targets, so our build is really speedy. If I do want to test on iOS, I don't need to test on every iOS target all at once. So I can say, just build the simulator target or just build the ARM64 target and skip all of the rest. So again, cutting down those variants is a big win. The Swift package generation, like I said, the plugin that a lot of folks started out using a year and a half, 2 years ago, hasn't been updated for M1 support. You can use a community fork if you want, or like I said, in our case, we simply rolled our own 2 tasks. It was quite simple. I also know that there are some other folks such as TouchLab out there working on things to streamline some of this work. I'm sure other people in the community as well. So I think this is something that you can either roll your own, or I think there'll probably be another kind of community accepted solution very soon. Syncing our Swift package, like I said, took a really long time because eventually our repo, when we started to get a lot of people working on this, which again is a good problem to have, it meant it was working, we were checking in more and more frameworks, and the size of our repo became, I think, 6 or 7 gigs. So anytime someone did a full sync of that, as you can imagine, it took a really long time, especially on poor internet. So the solution for this is to not do the binary sort of local distribution model where it actually pulls down the whole thing from the source directory, but instead is to publish the framework as a zip file that lives outside of your project. And that way it can check out the commit it needs, grab the package.swift file, then go into the file, look for the URL, and go out to that URL and download it. So it saves that download time for cloning the repo, makes the Xcode syncing way, way faster back into the realm of seconds as opposed to like an hour, and everything works well again. So this is something that we've validated this. We're in the middle of moving to this approach. When I get back from this trip, I'll kind of finish the automation of this, and we'll be back to nice, happy iOS developers. API usability, this is another important one. You know, as many of you probably know, Kotlin Multiplatform on the iOS side translates things into Objective-C. So if your team is using Swift, those APIs are not always the most convenient to use. Things like enums or sealed classes, suspending functions, default parameters, there's a lot of things that we really like on the Kotlin side that don't translate super well over to the iOS team. So you can do things like writing wrappers. There's libraries to help with code generation. Again, I know there's people in the community working on generating Swift sort of more natively as part of the tooling. All of those things can help. I also think the really important thing is to collaborate early and often with your iOS team and see what is working, see what you can do to your Kotlin code to make sure that the APIs that you're providing the other team are helpful. And then kind of the last one here, shared ownership is, I think, a really big one. Looking back on a year and a half, close to 2 years now of this, for the most part, most of our development and investment into this has been done by a couple members of the team, myself and our other Android tech lead. We've had people do little things here and there, but it hasn't been fully owned and embraced by everybody. Everyone's been happy to consume it, but not everyone has worked on it yet. So we've been trying to do more and more with shared ownership of the project, lunch and learns to help everybody understand how to build the project, how to write Kotlin code. And also, we've had a big push to make sure that all of our mobile developers know how to build both projects. And I think this is really key, getting people comfortable with that local development model and being able to validate early and often whether the code they're writing is going to work on both projects. I think that is really helpful. And if you're on a bigger team, maybe not everybody has to be doing that, but the people you want owning your multi-platform code, I think they should be able to do that. And so that kind of the last tip here, collaborate from the beginning, build that culture of shared ownership of this from the get-go so that it doesn't feel like something that your Android team is imposing on the iOS team, but rather think of it as one tool that your whole mobile team is embracing. Okay, so just to wrap up the takeaways here, again, I think it's helpful to let the problem define the solution. Don't just set out to use Kotlin Multiplatform. Look for the right use case, and I think that'll make the integration easier. Evaluate your technical factors, but also evaluate the human factors when determining whether or not it's right for your team. That, again, will make it a little bit easier of a sell. Start small with your integration. I think that the think like a library developer motto is very helpful. It's a very natural integration model. If you wanted to do something more complex, I think that works, but the library model has worked quite well for us and other teams. And finally, collaborate from the beginning, collaborate early and often. So again, like I said, if all of this was very fast, because it's a lot to cram in, we've got 3 more blog posts here that help detail all of this. It gives examples, CI workflows, all that stuff. Check out that stuff and be on the lookout for more posts where we'll try to talk through some of the other things that we've had to do to maintain this for our team. And yeah, that's it. If anybody wants to chat more Kotlin Multiplatform, I'm happy to do that, whether here at the conference or online. Feel free to send me a DM, anything like that. And with that, thank you so much.